Idaho National Laboratory is growing its capabilities and building new facilities. Here's an overview of our progress. The Advanced Test Reactor Complex is the heart of INL's irradiation program. 2 large facilities are currently under construction at ATR. The new maintenance support building replaces several aging structures, consolidating maintenance activities that were located in older buildings. The new facility will vastly improve working conditions and efficiency for the maintenance team. INL's protective force and its safeguards and security staff will be able to operate more efficiently in the new security building at ATR. The building includes a conference room and consolidates working space that is currently spread across the ATR complex and other INL facilities. INL also is making improvements to the ATR complex's utility corridor to support the new capabilities and new facilities that are being built. The complex's aging infrastructure is expensive to maintain and is not well positioned to support the long-term growth of the ATR complex. The Materials and Fuels Complex leads the nation in post-irradiation examination and development of nuclear fuels. Here, 3 new facilities have been completed or are under construction. The approximately 14,000 square foot Research Collaboration Building opened in the summer of 2019. It provides a location for visiting researchers to collaborate with INL staff. As one of the few non-radiological research laboratories at MFC, it is used primarily for prototyping and instrument development. The 20,000 square foot administration building will provide much-needed office space, 2 conference rooms, a large multi-purpose room, and a new cafeteria for the growing MFC population. The project is expected to be completed in the spring of 2021. Construction of a large sample preparation laboratory began in June 2020. The facility will provide world-class research capabilities focused on testing and characterization of nuclear structural materials and fuel cladding. Construction is forecast to take 3 years, followed by facility commissioning and operational readiness. As a national user facility, the Sample Preparation Laboratory will be broadly accessible to industry, universities, small businesses, and national laboratories. A $6 million parking lot and plaza upgrade project is underway to address inadequate parking at MFC. The upgraded lot will include about 650 parking stalls, electric vehicle charging stations, and improved drainage and lighting. Dedicated bus access and pedestrian routes will improve safety. Completion is planned in fiscal year 22. Improvements to MFC's utility corridor will update outdated infrastructure and provide the needed backbone for future growth. The specific manufacturing capability at the north end of the INL site produces tank armor for the U.S. Army. A new 17,000 square foot warehouse was built in August 2019. Funded by the U.S. Army, the project was completed ahead of time and under budget. In the summer of 2020, 2 roads leading to SMC were completely rebuilt. For many years, heavy truck traffic and harsh environmental conditions damaged Niles Avenue and Lincoln Boulevard. Repair crews removed old asphalt and the road base. The new road, built using modern techniques and materials, has resulted in a durable road to help support SMC's mission for many more years. New capabilities at the ATR complex include an upgrade to the Advanced Test Reactor Critical Facility. This reactor restarted on April 30, 2020, after a 21-month digital overhaul of its console and control systems. Advanced Test Reactor Critical is a low-power version of ATR that supports the operations of its more powerful counterpart. It does this by enabling precise calculations of neutron flux levels and other effects likely to be seen at different test locations surrounding the ATR core. The digital upgrade improves reliability and precision while reducing the downtime needed for maintenance. Several new research capabilities have been added at the Materials and Fuels Complex. At the Irradiated Materials Characterization Laboratory, researchers can get a more complete picture of material performance in the nuclear environment. That's because they can now measure multiple properties at the same time and on the same irradiated sample. At this lab, The use of focused ion beam instruments is being developed as a single platform to gather these measurements. Researchers are then better able to discern microstructure on the atomic scale, where radiation damage occurs. They do this by using advanced microscopy techniques on samples from the same area, prepared using the focused ion beam instrument. In addition to upgrading an aging ventilation system that had reached maximum capacity and replacing aging instrumentation, the Analytical Research Laboratory is adding new capabilities. Examples include laser ablation and laser-induced breakdown spectroscopy, time-of-flight mass spectrometry, and laser profilometry. These world-class analytical capabilities will ensure the laboratory meets the increasing demand for lower quantifiable measurements. During the renovations, the Analytical Research Laboratory completed more than 4,000 chemical and physical measurements in the last fiscal year. National Reactor Innovation Center staff are designing a testbed at the former site of the Zero Power Physics Reactor, which ceased operation in 1990. The facility is being modified to host reactor demonstrations and other advanced nuclear projects. At the renovated facility, one preconceptual design envisions lowering demonstration reactors into the building through a hatch in the roof. Once a reactor is in place, the confinement area could be safely sealed. The renovated test facility is being designed for work with highly enriched nuclear fuel that enables reactors tested here to be roughly 10 times smaller than commercial equivalents. A second test bed will be at the former site of the historic experimental breeder reactor 2. That reactor and much of its supporting equipment has been dismantled, but the dome containment structure remains. After substantial renovations, this facility will provide an optimal space for nuclear reactor demonstrations. It will be well suited for reactors that use commercial fuel, yet are still small enough to fit on the bed of an 18-wheeler. At the Research and Education Campus in Idaho Falls, 2 major facilities were completed in 2019. The Idaho legislature approved construction of both facilities and financed them through the state's Public Bonding Authority. The CyberCore Integration Center was designed to lead national efforts for securing industrial control systems from cyber attacks. It features 20 laboratories configured specifically for reverse engineering, testing, and improving the security of technology that is necessary for controlling assets such as the electric power grid, oil and natural gas pipelines, and water treatment facilities. The facility's mix of secure and open labs, offices, and collaboration space supports national security programs for agencies including the U.S. Departments of Energy, Defense, and Homeland Security. The Collaborative Computing Center is INL's Advanced Modeling and Simulation Research Hub. It houses INL's newest supercomputer, Sawtooth, which was ranked the 37th fastest in the world at the time of its installation. INL researchers use the center's high-performance computing resources to simulate reactor conditions and materials performance, studies that can improve the safety and reliability of today's reactors. Their work is also helping design tomorrow's advanced reactors, which are in development now. Through an online portal, collaborators around the country can access these computing resources to advance nuclear energy research and other scientific innovations. At the Energy Systems Laboratory, 2 large-scale projects are under construction. INL's new spark plasma sintering system, currently under construction, will allow researchers to study industrial-scale applications of this advanced manufacturing process. Modern energy materials need to withstand extreme conditions, such as radiation, heat, or pressure. The manufacturing of such materials is costly, energy-intensive, and cannot be incorporated into mainstream manufacturing operations. Relevant industries include renewable hydrogen production, advanced heat exchanger technologies, nuclear fuels and systems components, fuel pellets, reactor components, and advanced moderator materials. Construction is also wrapping up for an integrated energy system testbed, which will demonstrate how a nuclear power plant could efficiently divert electricity and heat to match variable demand. The power plant's heat will be simulated through the new Thermal Energy Distribution System, TEDS for short, and the Microreactor Agile Non-Nuclear Testbed, or MAGNET. TEDS is a versatile, non-nuclear, electrically heated thermal energy delivery loop that can represent energy input from a variety of reactor types. It will transport heat to a hydrogen production station, a thermal energy storage system, or other thermal energy users that could be installed later. By using energy resources more efficiently and economically, integrated energy systems reduce industrial carbon emissions while increasing power plant profitability. A new gamma irradiator has been added at the Energy Innovation Laboratory. The tool gives researchers the ability to probe how gamma radiation affects materials. The radiation chamber accommodates a wide variety of samples, and this capability strengthens INL's radiation chemistry program. These additional facilities and capabilities will ensure INL's ongoing success, which has recently been challenged by the novel coronavirus. Decisions made by INL leadership during the COVID-19 pandemic have been informed by the latest scientific data. We consulted health experts and adhered to established guidelines, which quickly led us to move a large portion of our workforce to telework. We required and provided masks for employees working in our facilities. Cleaning has been increased. Temperature checks are required of those entering INL buildings. On-site contact tracing has been instituted. Many tasks, including new employee orientation, our internship program, and tours, have been conducted virtually. Managers have been given resources and support to help caregivers and working parents during this difficult time. And through it all, across the lab, our workforce continues to deliver on our mission to discover, demonstrate, and secure innovative nuclear energy solutions, other clean energy options, and critical infrastructure.